Good morning. Today we are going to work on inverses of a function. This will be part 1. Today we're going to work on graphing and writing inverse functions. We're going to describe the relationship between the function and its inverse. And on part 2 we'll get into domain restrictions. So we're going to start off with explaining what an inverse is and some characteristics of an inverse. So our first equation, our original equation that we have here, is f of x equals 2x plus 3. And the table is already made, and the blue table goes with the blue line. Okay, so here's this equation. And here's the inverse equation. I'm not going to tell you how we found it, but I'm going to show you that this is a table, and this is the graph. And notice where this arrow is here. This arrow is pointing to y equals x. I want you to know, and I need you to memorize, that y equals x is where inverses are reflected over. Okay, and now with that information, I also want us to go to the table. My first blue point was -2, -1. Let's compare my first red point, -1, -2. Do you notice what happened here between x and y? They switched places. Reflection over y equals x. When you reflect over it, your x and y points are going to switch spots. So -1, 1, 1, -1. So again, these are going to switch. Your x's now become your y's, and your y's become your x's. So we know that if we have an inverse, the table locations are going to switch. All your x's become y's, and all your y's become x's. We also need to remember that it's a reflection over y equals x. So it's kind of like if we fold our graph right here, everything right here comes over here, right here. So if it's in the first quadrant, it's going to stay in the first quadrant. If it's in the third quadrant, it's going to stay in the third quadrant. The big changes are the second will move to the fourth, and the fourth will move to the second, okay? So again, we're reflecting over y equals x. One of the key things about inverses is some properties of domain and range. Now, we're not going to see it so much with linear, but we are going to talk about domain and range. So domain and range are also going to switch places. But now, because we're dealing with the straight line, and we'll go ahead and we'll work with interval notation, all linear equations, every single one has a domain of -infinity to positive infinity. And my range is also going to be -infinity to positive infinity. Make sure you're using parentheses. Now, is it a function, yes or no? So a function means that it never repeats x values. So you can do the vertical line test. It would be hard to show. A vertical line test means you get your pencil, you put it straight right here, and you slide your pencil over, and you make sure that it doesn't cross 2 times. As long as it doesn't cross 2 times at the same exact x value, then it is a function. So is this a function? The answer is yes. Now, our domain and range for the inverse means that the domain that you have now becomes your range, and the range that you have now becomes domain on the other side. Now, just be careful, though, because linear is always -infinity to infinity. So when you switch it, it's going to be exactly the same. That's not going to be the case when we start doing quadratics. But for this problem, they do switch places. My domain is -infinity to infinity, and my range is still -infinity to infinity. Now, vertical line test with the red one. Does anything repeat? No, it is a function. We will be getting into why that question is important on the next video. Like, why does it matter if it's a function or not? So there's a lot of things we're going to learn today. And hopefully this video is going to go through most of these today. So what we just talked about is the domain of a function is the range of its inverse. So if you can find the domain of your function, you have also found the range of its inverse. We just talked about the range of the function becomes the domain of its inverse. So again, those are just going to switch places. We talked about that the graph of the inverse is a reflection of the original graph around this line. So whenever you reflect over y equals x, your x and y's are going to switch places. This is a big part of today's lesson. We're not going to deal that much with number 4, but the product of a function and its inverse. So if you multiply the function, you multiply it by the inverse, you should get 1. Okay, it's a way for you to check your work. A linear function's inverse is a linear function. A square root function and a quadratic function are inverses of each other. We're going to talk about all 3 of these in detail right now. And then a cube root functions and cubic functions are inverses of each other. So when we say take the inverse of a cube root, you're going to have a cubic. If we say take the inverse of a cubic, you're going to have a cube root. So terms are going to be very important. Okay. So let's talk about a quadratic parent function. So the quadratic parent function is f of x equals x squared. It's this blue graph right here. Okay. I already found the inverse. The inverse of a quadratic is a square root. And what I had to do, if you can tell, I had to do the positive square root and I had to do the negative square root. So this blue graph, if I fold this blue graph over this pink line, which is y equals x, if I fold it over, this is where the graph ends up. So let's talk about the blue graph. What's the domain of the blue graph? Well, quadratic functions can go forever to the left and forever to the right. So my domain for all quadratics is negative infinity to infinity. My range is how low is it going to how high is it going. What's my lowest y value? Well, my lowest y value is 0. And how high up is it going to go? Well, it's going to go up forever. So my range, now let's talk about parentheses or brackets. Do I have a point at 0? If I plug in a 0 to my equation, do I get another answer? I do. So my numbers are going to have brackets, and my infinity is going to have parentheses. Is my blue one a function? So again, vertical line test. You get your pencil, you do a vertical line, and you cross through the blue, and you see if your blue crosses more than one time. And it doesn't. So quadratics are functions. Now, let's look at the red one. Is the red one a function? What happens when I do a vertical line test right here? What happens? Well, I have 2 points that cross at exactly the same time. So this is not a function. Just because my original equation is a function does not mean that the inverse is going to be a function. Now don't forget, guys, that these are going to switch places. And you can verify. Look at your red graph. What's my domain? My domain is my lowest x value. Here is my lowest x value for the red graph. So my domain is 0 to infinity. And this graph is going down forever. This graph is going up forever. So even though you think it's going, oh, they're just going to the right. No, it's going to the right and going up. So my range is negative infinity to infinity. So if you know your domain and range for your original function, you also know your domain and range for your inverse because they're going to switch places. Okay? Let's talk about cubic parent functions. Now, terminology. This is a cubic parent function. The inverse is a cubed root function. Okay? So this blue graph down here, it's kind of a pretty graph. This blue graph is my cubic. And we just finished doing cubics on the last video we did. So the cubic, what's my domain and range of a cubic? How far to the left, how far to the right? Well, cubics are easy. Cubics are going to have negative infinity to infinity for domain and range. And yes, they do switch places, but it's still negative infinity to infinity. So cubics and linears, those are the easy ones. The ones that we're really going to have to pay close attention to is quadratics and square roots. Now, if I do vertical line test, so let's look at the blue one. If I do a vertical line test with this blue graph and I shift this graph over, does the blue ever cross twice in the same spot? It does not. And if I do the same thing with the red one, it is also a function. How do we find the inverses? So I told you the inverses of the parent function, but now we're going to work on finding the inverse of any function, okay? So how do we find it algebraically? Here are the 4 steps we're going to do. Well, first of all, we know that f of x just stands for y. So we're going to rewrite it, and instead of putting f of x, we're going to put y equals 3x minus 1. Here's the key. Remember on the table how the x's and y's were switched? Well, part of that's because we're going to literally switch the x and y's. So we're going to take this value and this value, and we're just going to switch them. So now this becomes x equals 3y minus 1. And now to get the inverse equation, I have to solve for y. So I'm going to do the inverse operations. How do I solve for y? What's the first step I should do? I'm going to add 1 to both sides. Now I have x plus 1 equals 3y. Well, what's the next step? How do I move that 3 to the other side? I'm going to divide everything by 3. Now, I prefer, and there's 2 ways to do this. I could just do one big 3 there. I like doing it separately. So my equation is 1/3 x plus 1/3 equals y. Okay. So that is my answer. If you wrote x plus 1/3 equals y, guys, that is still actually correct, okay? I prefer the first one. So we just did the solving for y. Now we have to rewrite it in function notation. So we're going to go back to f of x, but if it's an inverse, my inverse is actually going to be inverse of x. So that reads the inverse function of x, okay? So the inverse function of x is 1/3 x plus 1/3. Now again, both of these are correct. I find this one easier to graph and easier to discuss, but you'll get full credit no matter which way you prefer. So we're going to do that repeatedly. We're going to find the inverse algebraically. So number 1 is to rewrite it and replace your f of x with a y. So y equals 2x to the 3rd plus 1. That is step 1. Step 2 is to switch your x and your y. So now this becomes x equals 2y cubed plus 1. Step 3 is now solve for y. How do I get the y by itself? Well, the first step is subtract 1 from both sides. Okay. Well, now I can't take the cube root yet because that 2 is not cubed. Okay, there's no parentheses around the 2y. So I need to move the 2 over. How do I move the 2 over? Well, I'm going to divide by 2. Okay, so now I have x minus 1/2. Now, how do I get rid of a cube? Again, opposite of cubing something is taking the cubed root. So I'm supposed to take the cubed root of both sides. I'm going to go ahead and rewrite it. This is what I have. And now the next step would be to take that cubed root. So the cubed root, it has a radical with the 3. Okay, and a radical with the 3. And those are going to cross out. Now, the rule is you cannot leave a fraction underneath your radical. And so I know it's a lot of information right here. just the rule is you're not supposed to leave a fraction under the radical. So I'm gonna show you how to get rid of a fraction. I promise at this stage I will not make you do one of these completely on your own. You're gonna have to make your denominator turn into a number that you can take the cubed root of. So the first number, and when I'm thinking about cubes, I'm doing 1 cubed equals 1. 2 cubed equals 8. 3 cubed equals 27. So I'm looking at 1, 8, 27, 64, 125. So what's the first number 2 can turn into? The answer is 8. So I'm going to multiply my numerator and denominator by 4. And the reason I'm doing that is so that I can pull out the 8 on the bottom. So now I have 4x minus 4 over 8. Now guys, I didn't change my equation. I basically unreduced it. Okay? And so now I can pull out the cubed root of that 8 on the bottom. But because the 8's on the bottom, it has to stay on the bottom, which means it's going to be a fraction. What's the cubed root of 8? The answer is 2. So it becomes 1/2 on the outside. And on the inside is 4x minus 4. And that equals 2y. Okay, so we are done. One small thing is to rewrite it in function notation. Okay, 1/2. Now, like I said, I will not make you do one of those on your own right now. So this whole step, I had to do it because it's, you know, we're not allowed to leave the fraction there. But it is a lot of information. Now would be a good time to pause the video, write this down, re-listen to it if you have to. Let's try example number 2. Okay? So step number 1 is we're going to rewrite it by taking out the f of x and writing y. What is step 2? Step 2 is switch these two letters. So I have x equals 3y cubed minus 6. Now, what's the next step? Add 6 to both sides. So I'm not going to show it. I'm going to add 6 to this side. Okay, and I added 6 to the other side, so the 6 is gone. The next step is divide by 3. Okay, so I have x plus 6 over 3 equals y cubed. How do I get rid of a cube exponent? Well, the answer is I take the cubed root of both sides. Now this 3 and this 3 divide to 1. Now the y is by itself. Now guys, again, I cannot leave a 3 on my denominator. So going back to these numbers, what's the first number 3 can multiply into? 3 cannot multiply to get 1. 3 cannot multiply to get 8. But 3 times 9 is 27. So I'm going to do it to the numerator and denominator. And I know I'm running out of room. My apologies. So 9x plus 54 over 27. What is the cube root of 27? The answer is 1/3. And then 9x plus 54 stays under your radical. And it equals to y, but we know that the last step is to convert it to interval notation. So that is my answer. Woo, it's a lot of information. So that's how we find inverses algebraically. And we're just going to practice doing it again. Okay? Some of them are easier than others, and I understand that, and you'll see that some aren't going to be that hard. So this first one right here, this is a Square root. What's the inverse of a square root? A quadratic, which is something squared. So we're going to have something squared instead. So we're going to rewrite it with y equals 2. Okay? That's step 1. And sometimes you already have the y there, and if you already have the y, you don't have to do that step. The next step is to switch the x and y. So x equals 2 square root of y minus 3. Now my goal is to get the y by itself. Well, what's the first step? The answer is divide by 2. So x over 2 or 1/2 x, just whatever you prefer. Now that y minus 3, you cannot add 3 to the other side yet because that 3 is underneath the radical. Well, how do I get rid of that radical? It's a square root. What is the opposite of square rooting something? The answer is squaring. But if I square one side, I have to square the other. So 1/2 x squared is now equal to y minus 3. What's the next step? We're going to add 3. So this problem has a b value. I'm going to add 3. And instead of y, I'm going to go ahead and rewrite it, the inverse function. I like to put that first, but even if I don't, it's still the right answer. So the inverse of that square root function is 1/2 x, all of that squared, plus 3. Okay? Hopefully that makes sense. If not, rewatch it. I want you to go ahead and try number 4 on your own. Okay, now you get to check your work, and I did make this one a little bit easier for you guys. Okay, so step 1, we rewrote it with the y here. It's red. In black, the next step was to switch x and y, which in black. The third step was, how do I get rid of the square root? The answer was I square it on both sides. I'm left with x squared equals y plus 2. How do I move the 2 over? I subtract it. So I have x squared minus 2 equals y. And I did have room to rewrite it better. The inverse of this function, if I graphed this one and graphed this one, they would reflect over. What line would they reflect over? They would reflect over y equals x. Okay? So they are mirror images of each other over y equals x. Okay? We're going to find inverses again. And then we're going to find the input when the output is -3. So what's output normally? Okay, find the input when the output is -3. When y was -3. Okay, so let's go ahead and find the inverse first, and then it would make more sense. We're going to rewrite it. Okay, step 1. Step 2, we're going to switch places. Next step is to solve for y. So subtract 5, subtract 5. I have x minus 5 equals 3y. Next step is to divide by 3 on both sides. So my inverse of the function is x minus 5 over 3. So that's inverse. We did good there. Now the next question was find the input when the output is -3. So I'm actually going to take this number and I'm going to plug it into the x after I switched. Okay, and I'm going to explain why this works, but let's find it and then we're going to explain it. And I'm not going to explain it every time, but I want us to know, why did that work? Output is normally my y value. Why am I plugging it into x? And I'm going to show you. So we're going to plug it in right here. So here's my inverse. I'm going to take this equation and I'm going to plug in -3 into my x value. So -3 minus 5 divided by 3, my answer is -8/3. So that is my answer, but I am going to come back and I am going to write it as an ordered pair. When I plugged in -3, I got -8/3. Now, don't forget though, that's for my inverse function. My original function, which is up here, it wanted me to find the input, find my x value. Don't forget that they switch places. So either way, the -8/3 is my answer. Again, we are doing our inverse function, which we've been practicing this whole lesson. And then, okay, we're just plugging in a number now. And so we're just plugging it in to figure out what the other value is. So try to find just the inverse on number 6. Hopefully your function, your inverse of the function came out correctly. To be honest, that's the most important part of this lesson, is making sure you can find the inverse. Now, we're just going to practice by plugging in a value. So this problem, again, we're just plugging in the -3. So we're going to take this equation and we're going to plug in the -3 into that value. So this is the number that I plugged in. So solve it. We get y equals, that's -1/-7, so it becomes 1/7. So my answer, my input would be that 1/7. But I'm going to write the ordered pair, -3, 1/7. So my original equation would be 1/7 -3. Don't forget the x and y's switch places. So it says find the input. The input would be 1/7. Now we're going to do, we do have several more to do just because we have linear, we have quadratic, we have cubic. So it's kind of hard to do just one question of each because then we don't get to practice any. So we're going to go ahead and do 2 quadratic. So the first one I'm going to do. So my first step is to rewrite it and I'm going to exchange the variables. So I'm already thinking ahead. And I wrote it as a y, and I switched them. So again, I switched the x and y. That's the whole point of doing the inverse. Now, how do I get the y by itself? Well, the first step is to move the 7 to the other side. How can I get rid of this 7 here? Well, I add 7 to both sides. So x plus 7 equals y minus 2 in parentheses squared. So I can't do plus 2 yet. I have to get rid of the squared. How do I get rid of the squared? I take the square root. Because the square root and the square divide to 1. So now I have the square root of x plus 7 equals y minus 2. Now how do I move this minus 2 to the other side? I add 2 to both sides. Now guys, when I add 2 to both sides, I cannot combine that with the 7 because notice that the 7 is under the radical. That radical kind of acts like parentheses. You can't put something in there. So I'm going to put the plus 2 at the end. And it is y, so that is my inverse function. So if I rewrote it, the inverse of the function is the square root of x plus 7 plus 2. If you're going to write that like in words, you can say the square root of x plus 7 and maybe like do parentheses around it and then do plus 2 at the end. Again, this wants us to practice plugging in a value. So this is my inverse. Again, that's the most important part. Now I'm going to plug in In place of x, I'm going to put a 2. Just so you can see what I plugged in. Okay, so under my radical is 2 plus 7. What's 2 plus 7? 9. What's the square root of 9? 3. So 3 plus 2, y equals 2, 5. So my ordered pair here is 2, 5. So don't forget for the original, it says find the input. And I wish it was more clear. It should have said like input of the original. So if I come back to my original, I flip it. Remember that x is input. That's why we're having to flip it. Y is my output. So when my output was 2, my input was 5. Okay. So try number 6 on your own. Again, I want you to go ahead and just find the inverse before we substitute the value back in. Hopefully you got the right inverse of the function. So I didn't show a lot of the work here. What did I do? I flipped it. What was next? I subtracted 4 from both sides. I didn't show it though. What was next? I took the square root of both sides, and this is what I was left with. Then I subtracted 3 from both sides, and this is my answer, but I wrote it in function notation, which is the inverse. This is inverse of the function, is this. I'm going to go ahead and skip the input and output. Let's go ahead and go to a cubic function. Okay, so here's a cubic function. So we are going to switch the x and y. So this becomes x equals. Okay, I'm going to go ahead and show all my steps here. First step is to move the 1 over. How do I move the 1 over? I add it to both sides. So I have x plus 1 equals y minus 5 cubed. Now, how do I get rid of a cubed? I take the cube root. Again, terminology is important. Cube root to both sides. This cube root and this cube divide to 1. They're gone. So I'm left with the cube root of x plus 1 equals to y minus 5. What's the next step? Adding 5 to both sides. Now this cannot go underneath the radical. Remember that radical is going to act like a grouping, like a parentheses almost. You can't put it underneath the radical. It has to go after. So this is my inverse function. And again, I am going to skip the input-output. Remember that plus 5 cannot be underneath the radical. Okay, go ahead and find the inverse of number 8. Hopefully you got this right. I will quickly explain it. I switched the x and y. Remember, this is a y right here. I switched them. The next step was to move the 2 over by subtracting it. You have to do the opposite sign. The next step was to take the cube root of both sides. And I did it on this side. I didn't show it. I took the cube root, which means the cube root and the cubed right here divided to 1, so they're gone. The next step was subtract the 3, and remember, it has to go after the radical. Now, major thing with this is we're going to find the inverse, and we're going to talk about domain and range. So we learned cubics in the last lesson. We talked about domain and range. If you don't remember, a cubic graph looked like this. So it's going on forever in both directions. My domain is negative infinity to infinity. So remember, cubics and linear. Now for the inverse, they do switch spots, but on these guys, does it really matter? No, but I'm going to keep saying it because it will matter when we get to quadratics and square roots. So even the inverse is going to have negative infinity to infinity. What is the inverse equation? So we're going to take this equation and just quickly find the inverse. So we're going to start with x equals y cubed minus 1. Well, what's the first step? We're going to add 1 to both sides. So add 1, add 1. We're left with x plus 1 equals y cubed. How do I get rid of that cube? How do I move it over? I take the cubed root of both sides. And when I take the cubed root of y cubed, I'm left with just 1. So my inverse equation, the inverse of the original function, is equal to the cube root of x plus 1. Number 10, my domain. Okay, do you guys remember square roots, what the parent function looked like? A parent function looked like this. It started at 0, 0, and it was like a half of a sideways quadratic, basically. So the square root of x plus 4. What is my domain? So that plus 4 shifted it to the left 4. So it went this way. And it started right here. Well, what number is that? It started at negative 4. And how far to the right was it going to go? Infinity. So guys, that becomes my range of my inverse. Okay? Remember the x and y switch places, the table switch places, and your domain and range switch places. Now what's my range? What's my lowest y value? My lowest y value is 0, and it's going to go up forever. So my domain of the inverse is going to go 0, and it's going to go up forever. Now let's find that inverse equation. X equals the square root of y plus 4. Okay, the first step is to square both sides. The next step is to subtract 4. Okay, and so my inverse equation, it says equation, so I could put y equals x squared minus 4. Sorry, I've been doing function notation, so that's kind of what's on my mind. Okay. So that's the inverse function. Okay, so let's try it again. Let's see if you could actually try number 11 on your own. Now this is a cube root. So don't forget, how do you get rid of a cube root? You cube it. So let's try it on your own. Hopefully you're able to do that on your own. I did give you a cubic just because to me that's one of the easier ones with the domain and range. Remember that cubics and cube roots are going to have all real numbers for domain and range, even on the inverse. What did we do to solve this? Well, I switched the x and y. First, I divided by 3. If you have x over 3 here, that is okay. You know, when you divide by 3, you're also multiplying by 1/3. It's the same thing. So if you have x over 3, that's fine. And then I had the cubed root of y plus 1. I cubed both sides. I didn't show it here, but I put a 3 here, and the 3 and this 3 divided to 1, so they're basically gone. And then I subtracted the 1. I had to put it outside the parentheses. Number 12. I know number 12 is a little bit harder, but try it on your own. Hopefully you did okay there. I know that square roots and quadratics are a little bit harder. So the square root, remember the square root normally starts here, but this graph went to the right 6, right? 6. So my domain starts right here. What number is that? 6. How far to the right is it going to go? Infinity. Range, what's my lowest y value? Remember the k there was no k, so my range starts at 0, and it's going to go up forever to infinity. And they switched places. And here is my inverse function. Okay, we haven't done quadratics. Let me do one on my own. I'm going to do one with you, and then you'll do one on your own, and that'll be the end of our lesson, okay? So we're going to start off by switching the x and y. Okay? A lot of things going on here, and we look at this, say, what can we do first? Remember that we leave that parentheses alone, okay? We don't do anything with that yet, and if it's touching the parentheses, we don't do it yet. So the first step is to subtract 3 from both sides. So x minus 3 equals 2. y plus 4 squared. Okay. The next step is to divide by that 2. So when I divide by that 2, I'm left with y plus 4 squared. Now, how do I get rid of a square? What am I going to do? Take the square root. So then I have the square root of x minus 3 over 2 is equal to y plus 4. Now, if you remember from earlier in this video, we cannot leave a fraction underneath a radical. This is a square root, so we think about squares. 1 squared equals 1. 2 squared equals 4. 3 squared equals 9. What's the first number that we can multiply this 2 by so that we can take the square root of it? The answer is going to be 4. So how does 2 turn into 4? I'm going to multiply it times 2 on my numerator and denominator. And I have 2x minus 6 over 4 equals y plus 4. Now, I can take the square root of 4 from the bottom. But remember, if I'm taking square root of 4 from the bottom, that's really like a 1/4. So it has to stay on the bottom. It becomes a 1/2 on the outside. Square root of 2x minus 6. And that's underneath the radical. Now, guys, one more step I'm going to go ahead and do here at the same time. I'm going to move this 4 over by subtracting 4 at the end. Whew, that was a little bit intense, okay? What's the domain of the quadratic? Well, remember that a parent function of a quadratic looks like this. It goes through 0, 0. This went to the left 4 and up 3. So it's still facing up. Now, if you don't remember, quadratics, my domain is always all real numbers. So the inverse range of a quadratic is all real numbers, or negative infinity to infinity. My range, since the graph went up 3, and it's going up forever, it's 3 to infinity. So my domain of the inverse is 3 to infinity. And I apologize if the problem got a little messy in here. If you need to rewatch it, rewatch it. Go ahead and try number 14. It's a little bit easier than 13. Go ahead and try it on your own. This one was a little bit easier because the parent function only shifted to the right 5 units with the vertical stretch. So going right 5 does not change my domain or my range. So my domain for quadratics is all real numbers, or negative infinity to infinity. That's the range over here. Because this graph, this like right here, it only shifted to the right 5, it did not change my range of the parent function. So it's going from 0 to infinity, 0 to infinity. For the inverse function, I switched the x and y, divided by 3, took the square root in red. Now, I couldn't leave a 3 on the bottom, so what's the first number that I can multiply 3 by in order for it to take the square root? Well, I did 3 times 3 because I can take the square root of 9. But it's on the denominator, so when I took the square root of it, it stayed on the denominator. And then how did I move over a minus 5? I did plus 5. Okay? So thank you for watching this video. I know it was a lot of information. If you want more of these videos, give this a thumbs up, subscribe to my channel, and I will be posting more educational videos.